Hi, folks. Thanks for being with us today for our Safety and Health Magazine webinar sponsored by eHazard. We will start the presentation shortly. We're going to give our audience just a minute to settle in. Thank you. Thank you again, everyone, for being with us today. We'll give our audience just about another 30 seconds or so to settle in, and we'll start the presentation shortly. Thank you. Hello, everyone, and welcome to today's Safety and Health Magazine webcast, Advancing Electrical Safety, Principles and Practices, sponsored by eHazard. My name is Barry Botino. I'm an associate editor at Safety and Health and a co-host of the On the Safe Side podcast. I'll be your moderator for today's event. Before we get started, I wanted to share that the views of today's speaker and organization are their own and do not necessarily reflect those of the National Safety Council or Safety and Health magazine. Any mention of a commercial enterprise, product, or publication does not mean the council or the magazine endorses those items. At the conclusion of today's event, we will conduct a Q&A with our speaker. If you have a question at any time during the presentation today, just click that Q&A button located at the bottom of your screen, type in your question, and press the send button. Also, after today's presentation, you'll be asked to complete a brief evaluation survey, but I'll tell you more about that a little later. This webcast will be archived. If you'd like to view this presentation or any of our past webcasts, please visit us online at safetyandhealthmagazine.com/events. Now let's introduce our speaker. Joining us today is Zahir Juma. Zahir is a professional engineer and partner at eHazard. He performs electrical network design, arc flash studies, electrical safety training, incident investigations, and auditing. Zahir also has published peer-reviewed papers on electrical safety, spoken at numerous conferences, contributed to the wording of the NFPA 70E standard, and he is actively engaged as a subject matter expert on the IEEE 1584 suite of standards. With that, welcome Zahir, and please take it away.
Thank you so much for that introduction, Barry. And hello, everybody. Good to be with you all again. I was saying to Barry, I can't believe it. We're in the second half of the year and it's flying by so fast. So we are going to touch base again in November, where we've got our next webinar. And then in May next year, I've got a special edition on hand protection, specifically from the angle of electrical safety. There's so much development in that area. Cannot wait to share that with you. And please look out. Hugh Hoagland and I have written an article on electrical hand protection that's going to be published probably around October, November time period. And the webinar would be based largely on that article, which would be in the magazine, in the Safety and Health in the, I've got to make sure I know which magazine it is, but it is in one of the safety magazines. So with that, today we're talking about advancing electrical safety principles and practices. I have about 42 slides, and the reason for that is I tried to declutter my slides while trying to get you as much information as I possibly could. Now, before we get started, one of the things that I need from you all is when I spend the time developing these webinars, I want to make sure that I'm adding value to you, because these webinars do not benefit me in any way. I want them to benefit you and help you. What I'd like for you to do is during the course of this webinar, or even if we're coming close to the end of it, just send me a message through your Q&A or maybe through the chat, whichever is the ideal platform, and let me know what topics you would like to see. What's of interest to you? What's going on in your workplace? What are some of the struggles? What are some of the things that maybe your engineering team isn't communicating with you clearly? Or maybe if you're on the engineering team or the operations team, what are some of your challenges? I'd love to hear this. And it just gives us the opportunity to develop webinars that are going to help you. So one of my goals always to make things practical. And I believe that safety sometimes become too much, just people's heads are in the cloud. It's just philosophical principles which have no kind of practical angle to them. So what I tried to do today is I tried to draw a blend between the head in the clouds kind of ideology angles, which is in a lot of the safety standards, but try to make it practical as well. So what we're going to do is we're going to end off today's session with a case history before we jump into Q&A. And we're going to kick off the webinar discussing standards, because electrical safety means a whole lot of different things to different people. So what's the point of our webinar today and what are we focusing on? And then we're going to jump into the nuts and bolts of the safety program, the electrical safety program. And then we're going to talk about practices and sustainability with regards to these. Now what I'm going to do is I'm going to hand over to Kevin, who's one of our moderators, and we've got a poll out here. And I just want to gauge the audience temperature kind of to understand where we all are. So there's a poll on your screen right now. If you could go ahead and complete that poll. Once we get the results, let's see, you and I may be surprised, or you and I may be like, oh, we knew that. Okay, so those of you who are just joining in, we've jumped into a poll. And the poll says my electrical safety program, ESP, the abbreviation for electrical safety program, is documented, specific to my work needs, and understood by my electrical workers. That could be your plant operators, your mechanics, your electricians, your engineers. Just need one answer. What are your thoughts on this? I just want to gauge the temperature of our audience today. All right. And looks like we've got the results. Okay, so I don't know whether you all can see these results or not, but it says 53% of you said yes. So 53% of you believe that your electrical safety program is good enough, it's in a good place, it's being maintained. About 16% of you said no, which means that you all would benefit a little bit more from today's presentation than the 53%. That does not give the other 53% a chance to fall asleep during my webinar. We'll try to keep it interesting. And I'm particularly interested in the 31%, because those who said unsure is where I am as well. Because when I worked in heavy industry, whenever I did something, I was always uncertain of how effective is this, um, even after having implemented some of these principles that I'm going to be speaking to you about. I still came back and I was kind of unsure because it was difficult to sometimes read between the lines. But there were certain gatekeepers that kept me on the straight and narrow and pushed me from that 31% who were unsure to the 53% that said yes, their program is in a good space. All right, with that, let's jump back into our presentation. The first thing I want to do is I want to talk to you all about standards for electrical safety. And before we jump into mandatory and consensus standards, folks, do you know there's so many electrical safety standards out there, but we got to understand that some of these safety standards talk to us about how do we build equipment, how do we design it, how do we construct it. Other pieces, other standards would talk about, well, what are the construction requirements for this? How do you demo it? How do you put it together? And then you get even other standards which focus on the maintenance of it, on how do you test it, on how do you ensure it is within certain tolerances of operations. And I'll run through some of those standards. So you've got the IEEE C2, which is the NESC, the National Electrical Safety Code. It's a very relevant standard to generation, transmission, distribution, as well as telecommunication space. All right, and that's in the first few chapters. I'm going to say up to chapter 3, where they cover overhead work, underground work, and obviously the surface level work as well. Right. Then we've got IEEE C37.20.2 and 3002.3, for example. And these hover around how do you do short circuit analysis? How do you construct electrical equipment? You've got the National Fire Protection Association, the NFPA, and their standard, the NFPA 70, the National Electrical Code, tells us how do we build something? How do you wire a house? How do you wire an industry? How do you wire large, heavy production facilities, right? And that's called the National Electrical Code. I'm going to jump on that word just now in the next slide. You've got the NFPA 70B, B for Bravo, that tells you the maintenance. You've got NFPA 2112, which talks about test methods for flash fire testing of clothing. Then you have the IEC standards, the International Electrotechnical Commission standards. So their standard 62271 part 200 talks about the construction of medium voltage switchgear. You've got 61482 that talks about the testing requirements and the specifications for arc-rated clothing. Then you have the UL standards, and they also have a close working relationship with IEC and other standards organizations as well. You've got 508A that speaks about control panels, and you've got UL 891 that's an all-encompassing standard with regards to switchgear assembly. So you can see that although these are called electrical safety standards, they're not really focusing on work practice. So when you and I are talking about work practices, now the standards become very, very, very narrowed because they aren't that wide of a net of standards that's talking about switch gears, transformers, motor control centers, panel boards, control panels, etc., etc. Now we get into the select few standards, and those are the NFPA 70E, arguably the foremost standards with regards to electrical safety work practice. Now, what's work practice? Work practice is, do you know, something may be constructed to operate in a certain way, and then we'll maintain this in a certain way, we'll demolish it in a certain way, we'll construct it in a certain way. But when a person actually works on this equipment, the practices that they implement, those are the standards that we are looking at. Things that tell me, how do I need to work safely? The NFPA 70E, Standard for Electrical Safety in the Workplace, is the leader in this space. Now, the Canadian standards, the CSA Z 462, not Z 462, because it's a Canadian standard. That is basically an adoption of the NFPA 70E, but the gold in this standard lies in the annexure, because that is where the Canadian standard goes in and writes up specific rules applicable to the Canadian workforce. But how it works is a lot of these principles are sometimes new and novel, and we then bring them into NFPA 70E. I cannot tell you how many good ideas have started off in CSA Z462 that have ended up in NFPA 70E. Then we spoke about the IEEE C2, the National Electrical Safety Code, and specifically Chapter 4. After you handle the first 3 chapters, which tells you how do you need to construct things, what clearances are required, etc., etc., Chapter 4 is fantastic because it brings it all together, and it says if you are working in an overhead space, if you're working in an underground space, if you're working at ground level, here's your clearances from a work practice, not a design, from a work practice point of view. Here's the PPE you need. Here's when you need it. And obviously, the one that you all are extremely familiar with is the Occupational Health and Safety, Occupational Safety and Health Administration Standards, the OSHA. And 1910.269 speaks about generation, transmission, and distribution utilities. OSHA 1910.331, those are the, that's the part of the standard we normally call that subpart S, S for Sally. And that speaks to heavy industry, and associated with subpart R, which is OSHA 1910.269, subpart R, and subpart S, which is 1910, the 300th parts of the standards, will be your construction regulations, which fall within the 1926 standards. So if some of you were looking for information, those would be good places to start. Now, Let's jump into this discussion with regards to mandatory and consensus standards. What is a mandatory standard? A mandatory standard is going to be one that is enforceable by law, and that law can either be federal or state. So OSHA, when referencing these standards, so you've got the OSHA standards themselves, right? We spoke about subpart S, we spoke about subpart R, but within those standards, and even in subpart I, 1910 subpart I, which speaks about PPE, for example, it would reference a standard, for example, the ASTM standard D120 for rubber insulating gloves, right, is referenced in that OSHA standard. So similarly, you would see other standards containing the word code. So when it says code, it becomes a mandatory standard. So the problem with OSHA standards, like you all have read ahead of me, right? Because I put my slides up here. So if you've read through now, you can listen to me, is generally they don't change. For example, the changes to the high voltage standard came after many years, but the changes went the changes were published in 2014, and they had a 12-month implementation period, which was 2015. Since then, there hasn't been any changes to that standard. So OSHA standards generally have that decades. It's in the time frame of decades. Whereas codes like the National Electrical Code, National Electrical Safety Code, those change within a 3 to 5 year period. So the NFPA standards, usually they have a cycle of about 3 years. And what I'm finding as well is that some of these safety standards have really reached a plateau, and I think they can probably look at considering changing those intervals from 3 years to 5 years, like the IEEE does. But hey, that's beyond our scope today. So I've had this question come up many times because you have a National Electrical Code, which may have a specification that's published. Like, let's say you publish something in 2023, right? That is going to be the latest published standard. But then you may only have the 2017 version that could be referenced in either OSHA or your state level OSHA. So we talk about Fed OSHA or state OSHA, right? And then you've got the edition that's referenced within Fed OSHA. So for example, and this is a good example, you look at the National Electrical Code, okay, the latest edition, and let's say that is 2023. One of the states that I'm working with, the edition that they have in force at the moment is the 2016 edition, right? And if you look at Fed OSHA may not have a date in there, but may have a standard which may have been adopted in the early 90s, for example. So if you look at the NFPA 70E as another example, latest publication version, 2024. There's a state that referenced the NFPA 70E, and the edition that they had, I think, was the 20, oh gosh, it was the 2018 version of that particular standard. And then if you look at Fed OSHA rules were actually from the early 90s, around 1990 to 1994. Those were the standard that were adopted. So from a compliance point of view, when do you all need to comply? Well, basically, read between the lines. If there is a mandatory reference that says that any changes made prior to this standard will be acceptable, then you don't have to make any changes. If it says that as of November 2024, for example, all plants and facilities shall be compliant, then obviously you've got November 2024 to become compliant with those. Another good measure is talk to your insurance providers as well, because your insurance providers are talking to us, they are getting guidance from us, and we are providing these levels of detail to them. So you can always reach out to them and have that discussion. Now, mandatory versus consensus standard. What is a consensus standard? For a standard to be considered consensus, generally it's open to the public. So that means that anybody who is affected by the standard has the ability to direct the language within the standard. Usually these standards are published through a standards organization like the IEC, IEEE, ASTM, and these standards are updated every 3 to 5 years. Now, they are not enforceable by law. So what that means is OSHA can say to you under the general duty clause, you are receiving a citation for violating, let's say 1910.335 because you failed to identify a hazard. They can issue you a citation with that sort of language. What they are not allowed to do is they are not allowed to give you a citation and say that you have not complied with the requirements of the NFPA 70E 2024, Article 110.3. It is not within their jurisdiction to be able to issue you a citation based on a consensus standard, right? Now, there's one thing I want you to be aware of as well, is that although you have public input, what you got to be careful of with regards to standards is that standards may vote and decide not to take the popular opinion, which is rare, but it is possible, because the committee that votes on it may not necessarily be a public committee. It may be a closed group of people who subscribe to that standard, people who are within that standards organization or that working group, for example. So you've got to be careful of this as well, because a lot of people take consensus standard as the law, and we got to be careful in terms of it is a consensus. It is what the majority has agreed to. It doesn't mean that it's going to work in every single situation. So there's a lot to be said for engineering judgment, for practice, for things that can be documented. Later on in the presentation, we'll even speak about the authority having jurisdiction. All right. So you read the last line on the previous slide, right? We said that OSHA cannot issue you a citation based on NFPA 70E, for example. But what OSHA has is something called a letter of interpretation. You can see the abbreviation up there, LOI, the letter of abbreviation. And what this letter of letter of interpretation, sorry, I'm mixing up my words here. What is wrong with me? Okay, the LOI, letter of interpretation. And what OSHA says, and I'm going to read this out very quickly. From an enforcement perspective, OSHA does not enforce the NFPA 70E. It enforces its own standard, but there are certain instances where within the citation, they may reference a good consensus standard where this information can be collected. And I'll give you a good example. So the 1910.335 says that the employer shall identify electrical hazards, and where such hazards cannot be mitigated, shall provide PPE that should protect the appropriate parts of the body against the appropriate hazard. Okay, so they are not telling you whether it's shock hazard or an arc flash hazard. Now, if you look at the arc flash hazard, none of the OSHA standards actually speak about establishing the arc flash boundary using IEEE 1584. IEEE 1584 is referenced within Appendix E of of OSHA 1910.269. Okay, but if you look at subpart S, right, because you got the citation on subpart S, subpart S does not cover the establishment of the arc flash boundary. This is where you will need to go into NFPA 70E, and NFPA 70E offers you two options for identifying the arc flash hazard boundary, which is the NFPA 70E table method, right, that can be used, and that's in Article 130. Or you can use the engineering analysis method, which is in Annex D. Preferably Annex D7 is the one that's very common and used widely. All right. So although they will not say that thou has violated Article 110.3 of the NFPA 70E, what they will do is they will say under the general duty clause of 29 CFR 1910.335, you have been found violating a certain clause. And within the definition of it, they would say that this particular citation could have been avoided if the following checks and balances were adopted, as could be found in the NFPA 70E or the IEEE 1584 standard. All right, so be very, very careful because you think it's a consensus standard. I've seen consensus standard be pulled into court cases in court and presented to the jury, presented to the judge. So be careful. Just because it's a consensus standard does not mean that you get away from it scot-free. All right, there is some level of responsibility that we have to it. So let's talk about mandatory OSHA standards. They tell us what is required. So for example, I use 1910.335. It says that the employer shall identify electrical hazards in the workplace, and where such hazards cannot be mitigated, shall provide personal protective equipment. Can you see in that language? It has not told you what is the hazard. That is where we need to get into the consensus standard of how. So this now is very specific, because the consensus standard like NFPA 70E would tell you specifically this is the definition of a shock hazard. When a shock hazard exists at this many inches away from an energized conductor, here's the PPE that you need. And then they will go on to give you a step-by-step approach on how to create an electrically safe working condition. So can you see the difference between OSHA? OSHA cannot be specific. OSHA has to cast a wide net, because OSHA is looking at giving you the opportunity to use standards that work for you. They cannot be prescriptive. And I'll give you reasons why. Now, there are downsides of consensus standards. They are written for all users. Okay, and I think we covered this here, right? So the downside of consensus standards is that they are written for all users, and it is impossible, even with a consensus standard, to be prescriptive to your workplace, right? And then these timelines as well. We spoke about the timelines. They are open to interpretation, because sometimes they tell you this is what you need without actually going back and tell you whether what you had in place was needed or not. So for example, in oh gosh, when was it? Some of you may be able to correct me, but I think it was the NFPA 70E 2012 or 2015 edition that did away with the hazard risk category 0, HRC 0, right? Oh, yeah. Scott sent me a message and he said he's lost in the code and consensus standards and numbers. Would be nice to have a visual map of these. Scott, you and I are both lost on those standards. There's too many. What I'm trying to do is get across the principles of what we're talking about. All right. So don't worry too much about the specifics. It does not talk to the broader sense of my webinar today. But that's good advice. I'll implement it the next time. We'll show a flow chart of it. All right. So consensus standard, right, is consensus and standards means that the majority, consensus, the majority agree to it, and standard, this is one way that we chose to standardize it. It does not speak about exclusive methods. So even if you think about the arc flash calculation, folks, there are so many different ways. You can use the NFPA 70E tables. You can use the methods for DC evaluation that's covered in the NFPA 70E. You can use methods published in the IEEE papers, through papers that give you different formulas and different equations. So alternatives do exist. What do we need to address these gaps? So NFPA 70E 2024, Article 110.3 tells us that users shall implement, which means obviously you have to create it. You got to create it first and then implement it, right? And document an electrical safety program. So that is what they are telling us to do. They are saying to be able to be prescriptive to your organization, to describe the timelines for implementation of certain things, or timelines for which, for example, training may be valid, or when retraining is required, when you come up with which standard, which software, and within that software, what module you need to use. They are saying that you need to create your own electrical safety program. You know what the good news is? You can download a completed electrical safety program from the internet. And do you know what the best part of it is? For free, absolutely for free. I went in earlier today and I went onto one of the search engines and look at all of the free ones that I found. In fact, I even found one which is a Word document. All right. So this is so, so, so awesome until they made it rain on our parade. So what they say is NFPA 70E 2024 states in informative Annex P1 that by itself, however, this standard does not constitute a comprehensive and effective electrical safety program. I went and had a look at these safety programs, and guess what most people are doing? They are paraphrasing the NFPA 70E, and they are copying OSHA, and they say, refer to OSHA section that. Folks, how many of your electricians, how many of your plant operators are actually going to sit in front of their computer and go and look at a particular standard within OSHA and a particular subsection within OSHA and be able to interpret it within the context of all the cross references that was in place before they finally made that statement, right? No one's going to do this. Now, what I want you to do is I want you to think about why would the statement be true in addition to what I've said. Why else? Just take a second before I click on to the next slide. Okay, so if you've thought about this, some of the reasons why NFPA 70E itself does not constitute a comprehensive electrical safety program. Number one, it's a consensus standard. It's not a proprietary method. Here, what the standards allow you to do is have somebody called the authority having jurisdiction. And this can be anybody in your organization that is knowledgeable on the safe work practices, has education, training, and experience to make a judgment call. So what this person is doing is this person can actually say that within the consensus standard, we have the NFPA 70E, we've got the following published papers, we've got an EPRI standard, Electrical Power Research Institute, we've got an EPRI standard, and after reviewing all of these standards, I have decided that we are using this method. You will not get that in a consensus standard. A consensus standard will not be that prescriptive, right? That's reason number one. Reason number two is NFPA 70E, OSHA, IEEE, ASTM. They don't know your plant or your processes. They don't know this stuff. And then if you look at your level of risk exposure, I mean, don't let me get you started on me driving and my wife being a passenger and our appetite for risk and our risk exposure. I mean, if you want to see differences of opinion, I mean, just jump in the back seat when I'm driving and my wife's the passenger, or my wife's driving and I'm the passenger. It's crazy. And some of you are probably laughing because this is so true, it's no longer funny. All right. So some people may say, hey, I bypass this interlock and I open up this motor control center every single day. Whereas another organization may say, hey, under these conditions, you are not allowed to open this motor control center under these conditions. So can you see, because your level of risk exposure and your risk appetite, what are you prepared to accept and what are you prepared to not accept, right? And remember, when things go south, everybody is a Monday morning coach. Okay, everybody becomes a Monday morning coach. So just remember also, when things land in court, when it is a lawsuit, when you've got to provide professional opinion on this, you cannot always look at things in hindsight. You got to go back to why were those decisions made. So when something goes wrong, just make sure that your risk exposure and your risk appetite is something that you are able to defend professionally. Okay, so be aware of those. All right, and then the next is, oh, this is a big one. This is a big one. A standard, OSHA, NFPA, they don't know your organizational culture. They don't know how people think. They don't know about the level of compliance that's required. How stringent do you need to be? How much autonomy are you able to offer? None of those are known. And then NFPA 70E, although it mentions this, there is no talk of continuous improvement. So we definitely have to look at these a little bit more, continuous improvement. And that's where the sustainability part of this webinar will discuss that. So folks, I'm going to pause here on this stream of, on this line of thought, and we're going to take a deeper dive in practices and sustainability section later on. But now I want to get into the nuts and bolts. I want to get into the weeds of this ESP, what we call the Electrical Safety Program. right? And I want you to, before we even jump into this electrical safety program, for those of you who are not familiar with this, electrical safety is always established against two hazards. Our first hazard is electrical shock. And electrical shock is simply whenever a worker has current through their body caused by contact or approach to energized circuit parts. Folks, think about water flowing through a pipe. Similarly, when you get charge, when you get the flow of charge, like electrons flowing through your body through an external circuit that's above a threshold that can cause harm, you are experiencing electrical shock. Now, there is no electrical shock if your equipment is in an electrically safe work condition. That means that you're in a zero energy state, and it is 100% guaranteed that that zero energy state is maintained for the duration of your work. Or if the equipment has no exposed parts, exposed means where you can unintentionally make contact with your body, a tool, an instrument. Okay, that is what exposed means. The worker does not make contact through any of those test instruments, and the worker remains more than 12 feet for low voltage applications, 150 volts up to 751 volts. It is 12 inches away. What is an arc flash hazard? The arc flash is the second hazard, and I mean, obviously, I'm saying one and two. You can choose whichever one is more important here. Both are obviously important. Would be the arc flash hazard. And arc flash hazard is simply when something fails, you get the breakdown of air, and that causes this like lightning strike, like the strike of lightning, or should I say stroke of lightning, within this energized piece of equipment. And folks, it's not actually a strike. It's actually multiple. It's not a stroke. It's a strike because it's multiple strikes within this arc flash. And so what they're saying is that if you do maintain your equipment, and if it's in a normal operating condition where, I mean, you can read that, then it's unlikely for an arc flash to cause injury. But the gatekeepers for when an arc flash becomes hazardous is when the arc flash energy is greater than 1.2 calories per square centimeter, or when the worker is outside of the arc flash boundary. And I showed you this video previously, but somebody could be working on a piece of equipment using the appropriate arc rated clothing, and you could have an unqualified worker, like maybe the machine operator or maybe a supervisor, that's observing the person performing work. So the person sitting here in front of the equipment, the sensors showed no burn, the visual observation showed no burns to that particular worker, but the mannequin in the back that's on fire with cotton clothing, you can see that that fire is just raging. And we had that fire go on for more than 4 minutes before we extinguished that fire. So, what are the elements of your electrical safety program for those of you who have not established this already? Number one, your program needs to be site specific. Now, some of you are wondering, oh, well, I'm a large organization. We've got our headquarters and we've got 20 different branches. Well, in that case, does your global program is your global program specific enough to cover the individual and the unique risks within each plant? If it is, then it does not have to be site specific. However, if there are finer nuances between each of these production sites, you have one of two options. You can either create a procedure to address whatever that delta is, whatever those additional hazards are. Alternatively, you can write a site-specific program for each one of these operating units, right? You need to create a policy for creating an electrically safe work condition. And what that policy, folks, please remember, a policy directs the organizational culture. A policy is generally signed by the CEO and C-suite kind of people, the owner of the company. Those are the people that would generally sign a policy document. Okay. What NFPA 70E is saying in a policy document is they want companies to acknowledge that they will first choose to create an electrically safe work condition before performing any troubleshooting or testing or any repair type of work which exposes a worker to undue electrical hazards and electrical risk. Okay, you've got to assess the hazards, and folks, you can all read through all of this. You need to direct specific PPE. Don't just say, select PPE based on the NFPA 70E, because that means nothing to a plant operator. It means nothing to an electrician. And then you cannot say, use this PPE. You need to be specific, because you need to say, for example, that a shirt and pant alone does not offer arc flash protection if the hands and the head is exposed, right? So here's where you got to be very specific, and you cannot give like nth degrees of options. You got to say, hey, here's the clothing that we're using. Take the red bag when you're working on equipment that has the orange label that says like 8 calories per square centimeter, or says category 2, or says level 2 or something. And take the orange bag, which has the flash suit, if it says level 4 or 40 calories per square centimeter or whatever. So that's the kind of detail that you will not find in the NFPA 70E. NFPA 70E will tell you, here's all the ranges, here's all the PPE that can work. You cannot work with all of alls. You got to work with specifics, right? Then you got to talk about safety training. When are you providing safety training? When are you retraining? Are you retraining everybody completely on the full NFPA 70E once every 3 years? Or for your organization, did you find it sufficient just covering the bare bones minimum? All right, that's what you've got to decide. Now, I've separated these requirements within the electrical safety program because we're talking about principles and practices, right? So the NFPA 70E requires principles, controls, and procedures. What do they mean by this? What is a principle? A principle is a foundational basis of developing something that directs everything else, right? So that is what a principle is. It is the foundation. It is the bare bones on which you build everything else. Think about it as the major headings within your electrical safety program. Your controls are what is going to be used to check that the principles are being adopted. So for example, if you said to somebody, a principle that we have is that we will always use a low voltage class 0 glove for any exposure. Well, then how are you checking? So part of your controls would be, number one, provide the glove. A second control would be test the glove. A third control, train people. And where is all of those languages? All of those languages are in procedures, in specific procedures. Now, procedure can be a standalone procedure, or it can be a larger section embedded within your electrical safety program. So let's look at these principles. What are some of these principles? And folks, I'm going to go through them pretty fast. When I get to the end of the slide, what I recommend is, for those of the 53% who said that their electrical safety program is in tip-top condition, what I'm going to ask those folks to do is to take a picture of this at the end of the slide, okay, when everything is here, and go back and check and ask yourself, do I have the following principles? And after you do that for principles, go into the controls. Ask yourself, do I have these controls? And then finally go into the procedures and ask yourself whether I've got these procedures. How do I know for sure that they are implemented, effective, and understood? Okay, because those are all different concepts. So maintaining equipment in great shape and displaying great workmanship. All right. That is probably, for me, it's the cornerstone, because if you design something correctly, you install it correctly, you work on it from a maintenance point of view in taking care of it, making sure it's in great shape. Someone always asks me, why do you clean the inside of your car so frequently? Why do you wash your car so frequently? Because I'm afraid that if it looks dirty, I'm going to stop taking care of it, and I'm just going to get occupational blindness and not be able to see the dirt, the oil leaks, the brakes which are squeaking, the V-valves which are shrieking. I'm not going to be able to hear all of those things, or I'm going to get too used to it. So we talk about testing for insulation integrity. The functionality, is everything working? Or do you say, oh, well, in this case, you got to stick your toe in this spot and you got to push here at that angle with this much force before you close the breaker. Okay. I'm kidding about this, but I've seen so many organizations have this problem. right? Where functionality has just gone out of the window. And then when you work on a piece of equipment, are you leaving it in the same pristine state? Great workmanship, is that present in your organization? And if it's not present in your organization, why are you tolerating it? Why are you tolerating it? Do something about it, right? And what can you do? And that's where you all come in. OSHA is not going to tell you this. NFPA 70E is not going to tell you that. And obviously make sure that it's built correctly. Then create this principle of this ability, empower workers to be able to do a task-based evaluation that, hey, if I stick the screwdriver in here, this is not going to end well, right? Not, hey, if I stick the screwdriver in here, I know it's pretty bad, but I've been doing this for the past 10 years and nothing has happened, right? So create this ability to have introspection, to be like foretelling of what could go wrong, right? And then obviously your equipment-based evaluation in, if you don't have a Phillips, don't stick a flat screwdriver in there just because you forgot to bring your Phillips screwdriver along with you. And then document a system to ensure pre-job preparation. This would include planning for every job, discussing the risk and controls with everybody that's involved in that job. We call that a job briefing. Documenting all unique, especially when you make a change, when it's a new plant, document the work practices and expect the unexpected. So moving on, with our principles, maintaining equipment, we spoke about that. We spoke about the task base, and now we go into identifying all electrical hazards, analyzing risk, and implementing practical controls. So these folks are called your risk assessment procedures. In there, you would incorporate your planned job observations, protecting employees. So now you got to talk about the principles of what do I do for electrical shock? What do I do for electrical arc flash and other hazards? So you can have continuous safety through design as part of your risk control strategy. What do I mean by that? It means that when I open the door, I'm not exposed to voltage. When I remove the cover, that there's a warning in place before I remove this cover. All right, that if equipment fails, it fails in a safe way. Providing and promoting the correct PPE that needs to be used, and assessing people's ability. That is so important. And how do you assess a person's ability? You're going to do this through the core principles that are included in auditing. So these are the core principles that are suggested within the NFPA 70E. Now, once you have these principles, the next question is, well, how do I make sure, how do I control them? There's 3 steps to the ESP. Number 1, develop the program. Number 2, provide awareness with regards to it. And number 3, implement it, right? But now you got to train workers as well on this, on not just the program, but the electrical safety program might be saying, hey, whenever troubleshooting a motor control center in an energized state, please take care of the following. So when you say what that following is, that bypassing the interlock, using insulated tools, using the correct PPE and stuff, when you document all of those, you need to make sure that folks are trained, right? And rules need to be exact. They need to be logical and a chronological approach to everything that you do. So identify the electrical hazards. How do you create those safety plans, right? So we want controls with regards to this in how do you make sure that people are doing these? Have you provided them with a template, for example? We're going to talk about this next. The control of hazards when elimination is not possible, and any precaution that's unique. And I can talk a bit more detail, but I see I'm running out of time and I've still got a few more slides that I want through. So I'm going to try and speed through these and cover kind of not the stuff that you're reading. So do you know, always we want to get to this electrically safe work condition. So part of your controls would be that every single worker needs to understand that you have to not trust electrical equipment, right? And the lockout tagout in itself, so many people forget this. The control of hazardous energy, lockout, tagout, de-energizing, all of those are considered electrical hazard exposure, both from arc flash and an electrical shock point of view. And then when we're saying to workers, be safe, well, how are you developing and keeping these approach boundary in clear visibility to the people who are working on this piece of equipment? And then the last step we'll get into is these procedures. So your procedures and your programs, your risk assessment procedure. Oh my gosh, I need to do a dedicated webinar on risk assessments. We started with the risk assessment webinar the last time. So the last webinar that I did a introductory dive into risk assessments. And since then, you will not believe the questions that we received in, hey, this is fantastic. I need more detail. What do I do in this case? What do I do in that case? The next thing that I'm going to suggest that you have in terms of procedure is talk to me about qualifications. Because I'm an electrician, because I'm an engineer, does not mean that I am qualified to work on a piece of equipment. How do you, as the owner of the plant, establish qualifications? Is it time-based? Is it for me to hit a certain milestone before I'm a qualified person? Do I demonstrate my qualification on live equipment? Folks, if you have not written this in a procedure and you think somebody else knows it, let me tell you, everybody else is looking at you, okay, to develop this procedure. And then with regards to electrical hazards, I spoke to you about the shock. I spoke to you about the PPE, the tools, the clothing. This is under the procedure section because you got to be specific. You got to be very specific. Okay, in terms of when performing work on this type of equipment that has this label, here's the specific types of clothing that's required. And then your safe work practices or your safe operating procedures, your SOPs, obviously we establish these once we have done our initial risk assessment, job briefing, job planning. All of that stem from these safe work practices. And then from an engineering point of view, any equipment and specifications. So have a quick read through this. I've shown you the slide before at one of my previous webinars. I just pulled it in because it's a good summary of what you would need, right? Now, folks, while we're talking about these, as I'm moving through them pretty fast, I'm going to wrap up pretty soon. So please have your questions. If you saw something and you felt, hey, Zahir, you should have spoken about this in a little more detail, drop me your questions and I'll know what you want to hear more about. All right, so let's jump into audience poll number 2. And I'm going to push this back to Kevin, our moderator. And this has to do with practice and sustainability. So my question to you is, if you make this claim, we have a continuous improvement program that includes supervisory work practice inspections on an annual basis, preferably, if not sooner, and 3-yearly review and updates to the electrical safety program. If that statement was made to you, would you say yes? Would you say no? Or would you say, well, I do some of these and I don't do some of these, so I may be a maybe, right? So okay, I'm interested to see what this poll shows. All right, and here's, oh my gosh, okay. So this is an interesting one now. I see after we started talking, we've got a majority, 37% said no. Another 37% said maybe. So that means that they are doing some of this, they are not doing some of this, or they not aware of this being performed. And a really small number, about 25%, just a quarter of everyone dialed in, said, nope, we're not doing this. All right. So let's talk about this then. Let's jump into practices and sustainability. Now, there's a lot of papers published out there. If you want to learn about continuous improvement, here are 2 really good papers that I enjoyed reading. They are slightly older, but boy, oh boy, they have such great content in it. Now, one of the things that we talk about when it comes to sustainability, and I know all of you know this, is a Plan, Do, Check, Act. Okay, so planning, determining the goals, and the methods to receive the goals. Here's where we go wrong in the planning phase, because we do not set SMART goals, right? Specific, measurable, etc., right? Applicable, and yeah. Now, obviously, I'm thinking about it, and I forgot what the acronym stands for, but I know the T is time-based, right? And then we're going to do the doing part of it, and then we're going to check, right, whether we are effective, and then If there are gaps in our check, we're then going to take appropriate action. Folks, I'm going to strongly recommend, for those of you who have not read this book, it's called What is Total Control? The Japanese Way by Dr. Kaoru Ishikawa. And it's been translated by Professor David Liu, I think in 1980. Yeah. It was published in 1985. Great, great, great read. So what we came up with is we looked at 6 elements: the written electrical safety program, the risk assessment, training, investigation, audits, and maintenance. And we came up with the envision, execute, evaluate, and evolve. Now, the one thing I'm going to do here, and this is completely free of charge. There's no ties or anything to this. It's basically a summary of what I'm discussing with you today. All of this is available on our website. So if you go to e-hazard.com and look at resources, all of this information is going to be there for you to use, okay? Because to me, the best type of safety program is the one that the plant has ownership to. No consultant should ever own your safety program and tell you how you need to work. That is why this information is provided to you free of charge for you to be able to use, right? So what did I create here? And I've got 5 more minutes. I'm going to run through these pretty quickly. Folks, I have covered this in detail on one of my previous webinars. Please find that webinar on continuous improvement, and you need to go through this because it is fantastic material. It's worked at large organizations, and if it's worked for them, it's going to work for you. Number one, you've got to get a multidisciplinary team on your electrical safety program. You cannot write this in isolation. You got to train people. Do not surprise people when they rock up for training and saying, hey, by the way, do you know a year ago we implemented our new safety program? Your program will fall flat. So you've got to create awareness, get people involved. For your training, don't just copy the NFPA 70E. Don't just reference things from OSHA. Don't just download pictures from the internet. Get stuff that's specific to your organization. Work with people that know how to train. Just because you are an engineer, a professor, a 40-year experienced electrician does not mean that you are a good teacher. Right? Let that sink in for a second. Audits are so important, but you got to be asking the right question. You cannot go on a witch hunt. And maintenance, please, 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 I'm going to ask you, please join the webinar in November. We're going to be doing a deep dive into electrical maintenance. We're going to be discussing those topics. It would be awesome, awesome if everybody who attended today can be present for that. Folks, I'm going to end off with a very, very quick case history. I know we're running out of time, but basically what happened here was that a fuse blew on a busway. The electrician put a ladder out, could barely reach over, changed the fuse, and tried to close the door of the bus plug. When the door didn't close, he tried to tweak this mechanism to make sure the door closes, and there was an arc flash, and he ended up with second-degree burns around his hands and his face. What were the gaps? The gaps here was obviously ergonomics, the angle of approach and visibility. So Article 130.8 speaks about, do you know, blind reaching, right? So, and then it also talks about the person failed to visually check what they were doing, one-handed testing. So wrong, right? Why do we do one-handed testing? You need 2 hands to check both phase and line voltages. And then obviously ladders. Ladders are allowed. All of you argue with me so much about ladders and say, oh, OSHA allows ladders. It's impractical to get a mobile platform out to this area. Folks, you have not seen the accidents that I've seen. Please think about ladders when replacing fuses in bus plugs. Human factors, at what point do you stop? When do you realize that I'm no longer changing a fuse? I'm now trying to fix a bus plug. You've changed from normal operation into service and repair type of work. Supervisory work inspections, when are they occurring? Clearly, this person didn't use the right PPE. Maintenance, why did the door jam? If it was properly maintained, the door would not have jammed. And safe work practices, so many things went wrong. Here's what I want to tell you, and this is my last slide. The ESP covered every single one of those gaps. Do you have a program that's just there for words and for nothing else? We need to be more principled. Right. And folks, with that, sorry, I knew it was going to be a long one. We'll try and take one or two questions very quickly. Barry, I'm going to hand back to you.
Great. Thank you so much, Zahir, for sharing your knowledge with us today. Before we start the Q&A, I want to let everyone know about the evaluation survey we're asking you to complete. The survey will open in a different screen after this webinar. Your input is very important to us because it does help us to improve our future webcasts. And Zahir, we want to start with a question from Stacy, who asks, for international companies in regard to work practice, what's the best practice for applying standards, and which standards should be followed as a minimum across all sites?
Yeah, so this is a great question. Generally, what we find is that the NFPA 70E is broad enough to cover more than a lot of the European standards and other international standards as well. And the reason for this is many other countries have a safety through design approach, but there are instances where workers do not comply. So having those work practices, I'm going to say that 70E has not let us down on our international projects.
Excellent. Looks like we have time for one more, folks, and we'll go to Cynthia's question. And Zahir, she asks, if something is listed with a CE rating but doesn't have a UL rating, is it still acceptable to use in the United States?
Yeah, that's a great question. And the answer to that is I would still recommend getting the UL rate. And the UL, remember, there's several testing organizations. Underwriters Laboratory is one of them, but there are several, and we have written an article that's available on our blog. So if you do a quick blog search, you'd find the answer to that. And the reality of it is that the CE mark does not get it necessarily listed and labeled for use in the US. So from a best practice point of view, we would suggest that you do a bit more research and not accept just the CE mark. The CE is a quality control program in Europe, and the US doesn't align to it 100%. And Barry, I know we're out of time for questions. I will commit to answering all of the questions that we didn't get to via email.
Absolutely. Thank you for that, Zahir. Unfortunately, we've run out of time today, but as Zahir mentioned, any unanswered questions will be forwarded along to him today. We thank you all for attending, and we appreciate you just taking just a minute to share your feedback via our survey. A big thank you goes out to our terrific presenter, Zahir Juma, and of course, everyone from our sponsor, Bulwark. This ends today's Safety and Health Magazine webcast. Take care, everyone, and have a safe day.